Good afternoon, everyone. Today it is 10th of July. It is sunny outside. It is summer, and we're here to do business in the field of agriculture. Okay, let's go. On Friday, 10th of July, join me outside for an in-depth discussion on agri-photonics. This is where smart gardening meets photonics. Many EPIC members are already adapting what they know to the challenges of growing healthy plants with the minimum impact on resources. We will discuss trends in developing light recipes, fine-tuning the color and intensity to grow specific plant species as fast as possible. Europe is booming in agri-photonics. In Finland, sensors on drones and satellites are key to spotting disease, droughts, and wildfires in their vast forests. And researchers in the Netherlands want to understand what light is doing to the plants and what is the plant doing with the light. We'll examine the important roles that near-infrared spectrometers, LIDAR, and big data play on fruit and vegetable farms. And let's not forget the ornamental plant sector. That's why we've partnered with AIPH, the International Association of Horticulture Producers. They bring the best professional growers, breeders, traders, and retailers. We'll match them with relevant expertise in photonics to help grow their sector. So put this in your agenda, Friday, July 10th at 3 p.m. Central European Time. Before then, I may find time to finish my new garden. Well, I didn't finish the garden, but what I did is we did manage to put a fantastic participant list for this beautiful afternoon. The purpose of this meeting is to find collaborations. I have to say one thing. I am so happy with the way that things are going. We started already on the 1st of April with the online technology meetings, and it has been overwhelming, the amount of interest, the amount of value that we have seen for the companies in EPIC. Today we celebrate our 37 since the 1st of April, and we only have 2 more to go until the holidays. We have one on microscopy with top microscopy manufacturers on Monday, and we finish on Wednesday with top car makers talking about ADAS and autonomous driving. And for those of you who are going to miss us, you're not going to miss us for a long time, because we come back. We come back, of course. We come back on the 31st of August. We already had the calendar for the online technology meetings on the Q4. We're going back to 1 meeting per week because we are optimistic on the way that people are going to be traveling on Q4. We never know. Let's see how the world is going to look like. This is our calendar. Top events already for you to plan. Please, for example, pay special attention to the one we have in disinfection of surfaces on the 31st of August, or for example, the one on water quality monitoring on the 9th of November. Any meeting that is interesting for you, you should be there because we want to find you potential partners, suppliers, and customers on this particular field. And Anna, we are so lucky. We are so close to the 600 number. I would like to welcome all the new members who are sending the form in the last days. Thank you very much for your interest. Please, all those companies who are not yet a member of EPIC, join this amazing adventure. It is not that expensive, and the value is huge. And also I would like to say thank you to the amazing team behind me, all these great people that you have seen in these pictures. EPIC has now 15 staff, 7 people with PhDs understanding the technology of every particular company of EPIC. And what we do is basically organize events, online or present. We give access to a huge network. We give access to investment. We have the biggest website to find a job in photonics, jobsinphotonics.com, and we provide all our members with market data. We buy market reports from Penguin, Strategies Unlimited, Thematis, you name it. We give for free to all our members, so all our members have the latest market data. And that's all I wanted to say, because I want to talk about a passion of mine. I want to talk about precision, horticulture, and gardening. First of all, thank you very much, our sponsor today. Thank you, Hamamatsu. If you are looking for any kind of laser component or optics or mid-infrared lasers or detectors, this is the company to go. The first company manufacturing and developing and distributing photonic devices worldwide. Thank you, Hamamatsu, for having us sponsor this meeting today. And now I give the floor to my co-chair and very good friend, Anna. Anna, what are we going to talk about today?
Thank you, Jose. So yes, today, well, you cannot imagine how much fun I had when preparing this meeting. So today we are going to have presentations regarding hyperspectral imaging, end users, for growing, also solutions for drone, hyperspectral solutions for drone. But yes, and all these talks will be useful to trigger discussions because the goal here is to establish new collaborations and to find what are the needs of the end users that we have in the room today, such as John Deere, Gamaya, and Lima Grain, between others. So then for that, we have the system integrators. At the same time, the system integrators will have needs in components, in what is the optics, in what is the sensors, cameras, also about the networks. And well, also to thank you to all the pilot lines with which we are participating, for example, the JPIX pilot line for indium phosphide photonic integrated circuits, and other pilot lines such as MIRFA for prototyping and going to larger volumes for chemical sensors based on mid-infrared technologies. Well, and also I would like to thank the associations with which we are working today, especially the EUMCA, but also the the International Association of Agricultural Producers. And I have to say that if you can go to the next slide, yes. That we just signed it. We are so happy because we signed a memorandum of understanding with the AIPH, with this International Association of Horticultural Producers. The goal of this collaboration is to push new technologies, to push new developments, new systems, following the needs of the end users that form this association for horticulture. And we have here Tim, and it's my pleasure to introduce you for the first time, but not the last. So Tim, would you like to share your screen and then to explain us what is this association doing?
Well, hello, and thank you very much for your very warm welcome. And we are delighted also that we have been able to sign this memorandum of understanding with EPIC. It really is an exciting opportunity to be able to bring the expertise and knowledge of your members to our industry. And the International Association of Horticultural Producers focuses on the ornamental horticulture industry. So the aspect of horticulture that is not what you eat. So the flowers, trees, plants, and so on linked with that. Our members are associations that represent the ornamentals production industry in different countries. So we have around 50 to 60 members and affiliate members, but they in turn represent hundreds of thousands of growers around the world in different countries. For companies, also you have the opportunity to join as an affiliate member if this you find is an industry of interest to you. We have a number of activities. Normally we have 2 meetings a year where we bring our members together and we put on conferences and events for them, focusing on the key issues that are relevant for the sector in different countries. We have a role of approving international horticultural exhibitions. These include trade show events for the sector, right up to large 6-month expos that take place, such as the one last year in Beijing, which covered 500 hectares, attracted 10 million people over 6 months. So we're involved in very large events too. We promote the green city, the importance of the use of plants within the urban environment and how that improves people's lives, as well as the link to food production in the city in this instance. And we support growers directly on technical issues, on environmental sustainability issues, intellectual property, and so on. We run conferences and events, and we produce statistical information through an annual statistical yearbook, which we've now been producing for 65 years. We run the International Grower of the Year Awards, an event which is held every January at IPM Essen in Germany, the largest trade event for our sector. And we run a group for flower auction markets, and we publish the bi-monthly magazine Floriculture International. FCI is free to subscribe to, so I encourage you to visit the website and just subscribe and you will receive it directly. And there's many opportunities for you to get involved in our activities if you'd like to. The next opportunity is our conference. This year we are holding it online, as will not surprise you. It'll be on the 15th of September. It's called Recovery from Crisis, the Future for Ornamentals. You see the link from our website there to sign up to it. It will include a section on the overall impact of COVID on the sector, then a section on the cut flower industry, and then a section on the container grown plant industry and aspects related to it. So I'd encourage you to join and to be a part of that, to learn more about this sector and the needs that we have for moving for the future. But I'd like to thank you again for this opportunity and look forward to working together to help take our industry further and to develop it further. Many thanks.
Okay, thank you very much, Tim. Yes, we are going to participate in this in your virtual conference, the 15th September, and we hope this is the first one of a very large series of collaboration between EPIC and your association. And now I would like to introduce the next association with which we are talking also about a partnership. So this is a super exciting day for me. I never thought I was going to talk about cannabis in an EPIC online meeting about medicinal cannabis. So Kate from the EUMCA, from the European Medicinal Cannabis Association, would you like to share your screen and tell us about what is your association doing?
Good afternoon, everyone. I don't know if there we go. It's a great pleasure to present you today. In the same way, Anna wasn't sure that she'd be talking about cannabis today. I wasn't sure I'd be presenting to such an incredible group of companies in this area of photonics, which I actually had to look on the dictionary to understand what it was. So, but I'm assured there is a lot of interest potentially from your group in medicinal cannabis, which is the main area of interest for this newly formed European association. We are actually, we were set up in November last year, so we're still fairly embryonic, but it was really, we've really decided that this is a very fast evolving industry, very exciting, very dynamic, but very unregulated. You obviously have the three areas. You have medicinal cannabis, you have CBD, and you have recreational. So in Europe, we know that recreational is not really going to happen. It's not really happening. CBD, there's some markets where this has become more interested, but really what we're seeing in some countries such as Germany now is that the cannabis is being prescribed for quite a few different medical conditions. And what makes us different is that we're the first non-profit, so we're a non-profit organization. We're governed by the Ministry of Justice in Brussels. We also have, we're the only cannabis association which is on the Transparency Register in the EU. And we really have a fantastic team of people supporting this. We have an eminent professor from the pharmaceutical world, but we have most of the people working with us are very experienced from the pharmaceutical sector, but we also have attracted some very big companies from the cannabis area as well. So if you look at our mission, it's not just about working as an industry group, it's about making the environment correct so that more patients can access medicinal cannabis. We understand that this is really going to be about ensuring for the consumer that they get access to these products, but also the best quality products available. We don't want to see situations where, you know, products aren't produced to pharmaceutical standard, people don't get the product that they're hoping for. So if anybody is interested in this, and I know a lot of people are interested in cannabis, believe you me, please come and have a look at our website, which is www.eumca.org. If anyone has any questions about it, we're really opening up now to different areas or to businesses which will support cannabis companies, which we have some growers on board as our members. Again, it may be an opportunity, if appropriate, for you guys to look at coming on as affiliate members. I hope that's quick enough for you, Anna.
Yes, thank you, Kate. It was perfect. Yes, I have to tell you that when Jose and me were Googling about high precision horticulture, the cannabis market came like super fast, you know, to our attention. And well, it makes sense. You need high tech there too, because the plant has an added value. So yeah, yes, cannabis industry is pioneer in taking a lot of let's say, monitoring tools. And well, now it's an industry for us, interesting for more than one reason, right? So thank you very much, Kate. This is, as I said to team, this is the first one of a lot of collaborations. And well, come back to you, Jose.
Thank you very much, Keith. Thank you very much, team. Nobody can do anything alone. So for us, having the support of associations who have the end users is eternally valuable. Keith, I love when you said that you had to Google the word photonics in the dictionary before this meeting. That was great. That's what we're looking for. We want to find people with challenges that maybe photonics can solve. It is enormously valuable to have you in the room. I would like to say that there are a lot of people in the room, even people who you are not seeing right now. This meeting is being broadcasted in YouTube, so I would like to say hello, YouTubers of the world. If you want to get in touch with any of the participants today, if you have interest in photonics or in cannabis, just let us know. All you have to do is send us an email at jose.pozo@epic-asoc.com with the company that you would like us to introduce you. This also goes for the people in the Zoom channel today. You can get in touch with each other with the internet chat, but if you want to get in touch with each other afterwards, all you have to do is send me an email, jose.pozo@epic-asoc.com. I love connecting the industry. I love introducing companies. I love getting people to work together. And I would like to introduce the first speaker today, who is a good friend of mine. He's Cornil. He's the CEO of LightTech, and it's a company that is always looking up into the value chain, making design solutions, making design helps, but also going into the instrument. He's going to tell us today how to design the lighting in a greenhouse. Jan, thank you very much for being with us today for the next 6 minutes. The floor, on the attention of everyone, goes to you.
Okay, thank you, Jose. Do you see my screen?
Yes.
Okay, good. So I should handle the 6 minutes. So I will show you today some solution using optical simulation software for horticultural lighting. And my company is involved in 2 different areas. The first one is providing software to the industry, optical simulation software. And the second activity is to provide optical scattering measurements. So basically, we are measuring and characterizing all the behavior regarding the optical scattering in greenhouse, for example. So one of the software we can use for such application is called LIDAR. So generally it's used for medical application, it's used in the automotive industry, it's used for display application, camera design, and in the lighting. And especially today we'll speak about horticultural lighting. So what kind of simulation we can do in a greenhouse, for example? So we can simulate things like sun and its effect, even the diffuse sky. We can design what is happening through the roof and design special roof. We can work on the interaction between the light and the plants. We can work on all the infrared exchange in the greenhouse. We can design the lighting feature. So that's one of the big use of the software. And finally, the software can also predict the efficacy in your greenhouse. So, of course, you are a special world, different from the photometry world, I would say, using specific units and looking at what you call photosynthetically active radiation, which is a part of the spectrum. And you are using these units called photon flux, where you are measuring the flux of light in micromole per second. And we can handle all these units in such software. So you just have to choose the right units, and then we can handle the photon intensity and the photon flux density. And for the ones of you who are not very familiar with such units, so there are some equivalents, for example, for SANlight between the two. So, I mean, this industry needs special features and looking at all the effect between the plant and the different spectra. So this is why this software can really define all the spectra units. So from the sun, from the LEDs you are designing using some spatial spectrum. For example, for the sun, you can download all the metronorm data. We can define the transmission versus the wavelengths for either the plastic or the glasses. And of course, the most important is what is happening at the plant level and defining the right spectrometer of absorption or transmission or reflection. So such software has an easy workflow where you create your part, define the optical property, define the LEDs, and then you can run simulation. And what kind of simulation we can do? So with more details, so you can really simulate the sunlight, and you can really trace curve of the efficacy versus the hour during the day or during the months or during the years. And you can really design either the direct sun or the diffuse sky. So we have a lot of libraries in order to predict the sun on any position on the earth and at any time during the year. You can create virtual source representing the whole year. I mean, we are taking all the different irradiance we'll get during the year and create one source that you can use in front of your case in order to simulate 1 year at once. Then we can design the roof itself. So either it's just a flat plate, that's I guess the easiest, but some design includes some macro texture on the glass itself, so below the glass actually, and we can design this in order to create the effect that you want to reach. Then we can design the lighting feature itself. So there are different solutions. Either you just use modules from the vendor and we can place them above the plants and predict the lighting, or we can really design the reflectors or the lenses itself. Of course, when you will use an optic, whatever it's a reflector or lens, you can like this transform the photometry of your system, the beam and gold. So in case you are using lens, those software includes some optimization capability, which means that you say, you ask what you want and the software will modify the shape of the lens in order to get what you would like. So it's applicable with lens, but you can also use these with reflectors, and same software will optimize the shape or the position for what you want to get. And we can also work for different level in the greenhouse. So we're not only for one thing. You need to analyze the wavelength distribution, again, for different planes. That's something we can do. And you can also optimize your design in order to get the effect you want regarding the spectrum and different levels. And to finish, I would say that we can also go one level down and going at the level of the interaction between the light and the plant itself. So you have here an example, not with a plant, but with wings of a butterfly, where actually you can, I would say, enter the micro shape of the wings, and then we can really simulate the light distribution versus the angles or the absorption for this microstructure. So this is working with plants, and we can handle this. And so as a conclusion, we can do the job for those kind of simulation. And so I invite you to come back to us if you have any design to do or if you have any needs of software. That's it, Jose. I'm on time.
You are on time. Thank you very much, Jan. That was a great presentation. Now you are an expert on epic events. You know what is coming. This is the epic question. What can they do for you and what can you do for them?
Okay, I made a slide for this, so maybe I can share again my screen.
Yes, you can.
Actually, I thought that you would present it, but I can do it. Yeah, so what are we looking for? So first, more customer for our software. This is obvious, but so feel free to come to us. But we are always looking for partnership. So we are always looking for new materials. There are more and more material. Our user needs this data in software to get simulation. So if any of you are designing some new strengths, please be in touch with us and we can measure this data, most of the time it's free because we have interest to get this in our libraries. And like this, it's available for end users. So if you are a material vendor, we need partnership there. Same with some research laboratories or companies to work more on the interaction between the lights and the plants. So in case you just need some optical engineering, so that's something also we can do. But I would say the main partnership we are looking is mainly for the materials.
Fantastic. We have lots of those here. So I'm going to first ask if anyone has any questions. Raise your hand for any questions. You know, Jan, it's always at the beginning. People are shy or people are finishing their coffee after lunch. There will be a lot of questions, but then you know the rule. If there are no questions, I ask the questions, and I have a lot of friends today in the room, even friends in the Netherlands, friends from Wageningen University. Rick, how are you doing? Hello, Rick.
Hello. Yes, I am here.
You should all know that Rick is actually one of the drivers of Agri-photonics in the Netherlands. Could you tell us a bit about what you're doing in the field of agriculture in the Netherlands, and then we'll see what kind of match there is with the presentation we just heard?
Yeah, yes, I'm working at Wageningen University in research. On the one hand, as a business developer. On the other hand, as a senior scientist, and I'm at the moment supervising the construction of a new research center, which is completely focused on measuring plants on fields, in greenhouses, and also in growth rooms. And it's all about measurement, so it's all about lighting systems, camera systems, and other optical sensors to collect performance of plants. So it's highly connected to novel tools in the photonics domain. And we are really searching for the cutting edge technology to measure what's going on inside those plants or visible from the outside of those plants to understand actually the genetics. So to optimize breeding trials, to give farmers and growers more insights in their plants to run their facilities in a more efficient way.
Fantastic, Rick. This is the EPIC meeting, so you also get the EPIC question. What kind of challenges, what kind of problems you think the supply chain of photonics, hyperspectral, near-infrared, mid-infrared can do to help you?
A lot. So I really see the photonics domain as a candy store. A lot of new tools coming out. So hyperspectral imaging has been here, I don't know, for 20, 30 years or something. But still, a lot of improvements are made. So noise levels go down, lighting systems are more suitable for hyperspectral imaging. And this is, I think, my quest. I don't know for sure what's coming out soon, but it could, in our niche, solve specific challenges. So it's very interesting for me to understand what's coming. So,
thank you very much. Thank you, Ulrich. And I'm going to come to visit you very soon because I want to see that greenhouse. From the Netherlands, I'm going to go to one of the most beautiful cities in the whole Europe. It's called Bath in the UK, very close to Bristol, where I did my PhD. And for those of you who don't know Professor Wang, you should see a YouTube video, which is a beautiful, beautiful story. But I want you to tell us, Professor Wang, what did you join this meeting and what is Yes Health?
Hi, everyone. Good afternoon. And I joined this meeting, sort of trying to learn the photonics applications into the plant. I think from the Wageningen universities and other sort of the presentations, and we know that there's a lot of application of the photonics in the plant growth. Plant is like the light to the human being is the same thing. Light is quite sort of critical to the health of the plant. So my research work, I started with the solid lighting work and sort of back in the 1994, and I moved on to the laser work. And in the later sort of last sort of 10 years, my interest has shifted to the lighting for the plant growth, and using the lighting to control the plant growth and control the nutrition. But also the main thing is actually using the lighting to control the disease of the plant. Actually, it's a lot of interesting sort of impact, and just not just wavelengths, but the modulation frequencies, and can impact on the disease control of the plant. So that's part of my research work, and then I co-founded and started working with entrepreneur and on starting a Yes Health Eye Farm. The so far is, I would think, is one of the largest sort of the vertical farm in Taiwan that currently produce around about 1,600 kilograms vegetables and herbs per day. And we built a second one in Shenzhen in the Foxconn's the campus. That's 2,500 kilograms per day's production. So we have about sort of experience for about 9 years now, growing the indoor farms and with the indoor lighting systems. So that's kind of my background, the work, yeah.
Professor Wang, I saw the video. I got goosebumps because you told us a story that you saw a need for people to eat healthy, and you saw that eating healthy starts by growing healthy food, and you realized that high tech was the driver of that. So you had this vertical farming idea. It's such a beautiful video. I will recommend for everyone to see it. But most important, this is a business meeting. So I have here people from Seoul Semiconductor, from SANlight, from C-LED, from Light Tech. Do you have a couple of challenges for us when it comes to lighting in a vertical farming environment?
Yes, I mean, first is the lightings, if you use, and as it's still very energy intensive kind of unit, and so usually the lighting application side, we looking at the efficiency is quite important, but the efficiency wise is not just the adjusting the efficiency of the light bulb itself. The lighting design has to be, in a way, kind of switching before use and not use kinds of. For example, the lighting, we use half of the lighting in the air cells, and so basically the panel can be slided. When the half of the plant is in the daytime, the half of the plant is at the night, and then when the panel switching to the other side is starting the daytime and nighttime cycle. So we halve the lighting unit by doing so. So there are still many innovation we're looking for and searching for and to collaborating with, and see that we can increase the efficiency of the lighting. And
Professor Wang, be prepared because I'm going to make a lot of introductions of people who want to talk and discuss with you, and also, of course, with Rick from Wageningen University. Jan, what do you think of these two potential partners? They are great, right? I also have a question for you. There's a question from Bram, from Ophir. Bram, what's on your mind?
Let me see if...
Yeah, we can hear you.
Yeah, okay. What's on my mind is I wanted to know what the advantage is if you simulate also the sunlight, if you already know the averages and you already know the minimum and the maximum light levels in wintertime. So you know what kind of additional lighting you need. What's the advantage of still simulating the sunlight in the greenhouse?
Basically, it's the request of users. We never know. Some of them needs a lot of details on the sun position, depending on the position on Earth and so on. And other ones, they just don't need any information on the sun. They just go for artificial light, and that's it. But so we can do both. That's it.
Okay.
Fantastic.
I really understand for greenhouse producers to really want to simulate different kinds of light, diffuse glass and everything. But for lighting fixture developers, I don't really see the use. Of course, I see the use for your software tool in developing the light spectrum and the optics for it, of course.
We're going to have later on, we're going to have the presentation from the system integrator. He's going to shed some light into that. But I would like to hear from Ophir. You told me I am very active in the agriculture market. Could you tell us in 20 seconds, what do you do in agriculture?
Well, I have been active in the horticulture industry prior to joining the Over company. So I was working for BOV, selling also horticulture lighting. So I've also traveled to the US and was of course involved in the cannabis industry there. So I know a little bit about that topic as well. And of course I was very much active also here in Europe and Asia. Now I joined Ophir, which is a measurement company, mainly known in the laser industry. But we now also develop devices for the LED industry, which you can see in my background. This is one of our LED measurement devices for LED fixtures, where you can measure a whole fixture and the total output of the light.
Bram, actually, Rick from Wageningen would like to comment on your question. Rick, what's on your mind?
Yeah, I wanted to show you this impression, actually. I think this will also create some enthusiasm. Hopefully you can see my screen.
Mm-hmm.
Yes.
This is these are growth rooms that we have in mind. So we are currently building these growth rooms. In there, we do breeding on plants. And we have those artificial light systems that mimic sunlight as close as possible. And we are studying with cameras how the different varieties respond to different light conditions. So these are all LED lights that are giving treatments to plants. So they're not used to make images, but they really function as a sunlight generator. We take images, and we've noticed that differences between plants exist, between varieties. And we are searching for the specific genes that respond to this photosynthetic mechanism. And in that way, we can steer the breeding program towards, you could say, more light efficient plants that grow faster in low light conditions, or that grow faster in high light conditions, or they are able to cope with different lighting settings anyway. And this is our reason to demand these sunlight characteristics.
Rick, a lot of people are going to connect with you after this slide. I can see my friend from Seoul Semiconductor already smiling at this. But we are going to go to the next presentation. We go now to the system integrator. We go to SANlight solution. Thank you very much for being together at this meeting. Is your second already online technology meeting? You like the first experience, so you repeat. The floor and the attention of everyone goes to SANlight.
So, thank you for that. Can you see the screen?
Not yet. I guess it's somewhere on the way between Germany and the Netherlands.
Duck.
Yes, it's almost here.
It's better now?
It is here. Could you go to slide mode, presentation mode? Yes.
I will do that.
The floor is yours.
So perfect now. Good afternoon. Thank you very much for inviting us to present our activities. We are located in Austria, in the heart of Europe, and we are working with LED lighting only, but I will show you in this slide. So our approach was to have a company called SANlight, which the two gentlemen up here founded 10 years ago. And they're coming from the biology side, from the growing side. And the other shareholder is the company Lumitec, which is one of the pioneers here in Europe with LED lighting, working with these light sources since more than 23 years now, even at that time already with white LEDs. Lumitec is in the niche. Food lighting, for example, in all retail stores around Europe, you will see most probably products from Lumitec shining on these fresh food or on the frozen food, for example. And these two companies decided a couple of years ago to found the company SANlight Solution. And the emphasis is here with the heritage we have from the technology side and the growing side. On the solution, it's not on the light, on the luminaire. We are focusing with our solutions on four segments when it comes to products. It's edible plants, ornamental plants, medicinal plants, and algae. Whereas medicinal plants is probably a lot of cannabis at the moment, but we see also very special plants in this area, which is emerging. What we divide into 5 segments, application segments. So the first one is plant propagation in nursery. We have first heard that already from the University of Wageningen. We have emerging business here in Europe when it comes to vertical farms. We have the greenhouse with the trailing plants like tomatoes, cucumbers, and so on. And we have the greenhouse with ground level plants like salad and potted herbs, for example. And what is also emerging as an industry is algae production. We serve with our lights worldwide already. A decade of experience with plants grow under LED light means that we are working with our customers. We grow with our customers. We're out there a lot. And with this field experience, we have, of course, solutions that we develop for sustainable production. And that leads me to the next slide, which is controlled environment agriculture. That's a term that is used when you try to exclude, let's say, outside effects and focus on a optimized use of resources and production yield, but also maintain tastiness and quality of the harvest. That's a very important part here. And the main drivers why we see this as a growing business is that you want to reduce the water consumption, that you want to minimize the use of space and use, for example, this picture here, this was a Coca-Cola storage hall. And now it's producing cannabis on 2 levels in there, and this is in Switzerland. So minimize the use of space, optimize energy consumption, low capex, so capital expenses. In a lot of places in Austria, you're not allowed, for example, to build a greenhouse anymore or a glass house anymore. So, and then of course, it's a thoughtful assignment of personnel when you start such a business, because it's quite cost driven. And this is as a result is you need hydroponic systems. You go into vertical farming, you have year-round production in the defined environment, and you go to Horticulture 4.0. And this means light is a driving factor. So the plant physiology and the illumination with artificial light in this controlled environment is key. And you have, we define 7 parameters here that have to work together, that have to be combined in a smart and good way, so that you end up with healthy, tasty, and good quality harvests. So, and this is also already the end of my presentation. What we are looking for as SANlight solution, we are looking for partners that we can team up with to create smart control grids and solutions for these questions that are to solve. So we grow with your plants, and we thank you again for the invitation.
Thank you very much, Christian. Super interesting presentation. Okay, then maybe you already said, but maybe can you summarize in 1 sentence? What are you looking in this kind of meeting?
So in this case, I have to repeat it. We are looking for partners for sensors, for measurement equipment in a closed environment, in indoor production. It's not so much into glasshouse. Here we have a good setup, but in indoor production where you have no daylight coming in, it's only artificial light. It's hydroponic systems, so that you control the nutrients, that you control the water flow, that you control everything and get more and more smart and farm.
Because when you mentioned the hydroponic systems, what are the difference in with regarding monitoring, regarding sensing solutions for hydroponics? I mean, what are the difference when you compare with a normal greenhouse?
So in greenhouse applications, you can also have hydroponic applications. That means basically that you have no soil anymore, or even you get rid of the substrates. And then you have only the roots and the water and the nutrition and ingredients there. And this is hydroponic systems. And there are different subcategories like aquaponic and so on.
But in terms of monitoring, in terms of sensing, do you think that these systems have special needs?
There are systems out there that can be used, yes. But what we see is that the ecosystem is not really perfectly set up and smart enough. It's still too expensive, and it can be streamlined. That's what we see.
Okay, we have a question from Bram from Ophir. Bram, would you like to make the question by yourself?
Okay, sorry to ask so many questions, but I was interested to hear from Christian what makes SANlight unique compared to other lighting suppliers.
Well, as I've mentioned, SANlight as a company is one of our shareholders. They provide the lights. We don't provide the lights. We provide the solution. So we integrate light, we integrate illumination, but we go beyond that. We combine it with all the and this is the focus on vertical farming and indoor farming. We combine it with all the other things that you need to grow healthy and tasty crop.
Okay, and
so it's the solution. It's the solution based on the illumination. That's where we come from, but it's the solution that we came up with.
Okay, I have a second question that I didn't type yet. But since you were talking about aquaponics and hydroponics, have you also tried illuminating the roots in the water?
This is currently done in a research project with one of our customers or partners, and I don't have the latest results on that, but they're trying it. And it's also not anymore only in the visible spectral range, but we're also going to the UV part and into the infrared, near infrared part with our, let's say, when it comes to illumination.
Okay, thank you.
Okay, and now let's go all the way to France because we have a question from Jakes from Thematis. So would you like to unmute yourself and make the question?
Yeah, hello. Jacques from Thematis. You mentioned algae bioproduction, so it's no more. So it's not the same that for horticulture, where you have specific needs linked to turbid media or something like that for measurement in algae bioproduction. In terms of measurement, what you need to measure.
Yes. Hello.
I think the question from Jacques is for Bram, right?
Yes.
It was for SANlight.
Okay.
You mentioned you are working in algae bioproduction, and so it's turbid media, and perhaps I wanted to know what are the needs in terms of measurement, in terms of spectroscopic devices, to know what is required in this kind of production. Are there specific devices, or is it spectroscopic devices? Usual specific spectroscopic devices.
When you ask for spectroscopy, do you mean the visible spectral range, or going into the infrared as well?
Let's answer. Yeah. What spectral range do you normally look at? What spectral range do you measure? Are you looking at the visible? You go into the infrared.
So when it comes to spectral information that we want to collect, we really work already from UV to the near infrared spectral range. So let's say it's going from 260 nanometer up to 1030 1500, 1700 nanometer.
It is great because today you're going to hear from Senorics, from Gamaya, from Avantes. We're going to cover the whole spectral range for you. Back to Anna.
Okay, yes. So there are more questions for SANlight. Okay, because if not, I would like to introduce you a person that we have here in the room, an end user. So we have Piet from Lima Grain.
Yes, hello.
Hello, Piet. How are you doing?
I'm fine, thanks.
Okay, would you mind to explain what is Lima Grain doing?
Well, in fact, Lima Grain is a seed development company, let's say. So our business really to sell seeds and for agricultural and also vegetable crops. So that means that, for example, we will develop new seeds with better yield, better disease resistance, and so on, for corn, for rape, barley, wheat, and so on. But at the other hand, also for tomato, melon, and so on. Okay. And specifically, I'm working in the research part of Lima Grain. So the part where we are really developing the new varieties, and there I'm busy measuring the quality of the crops from different platforms.
And Piet, any specification that we need to take into account when talking about seeds, about producing seeds?
Okay, well, I'm globally interested, of course, from my point of view, not talking about the other divisions in Lima Grain, but I'm mostly interested in how you apply or can apply NIR from different type of platforms. So I have already quite some experience in the laboratory itself and also on harvesters, but we are looking, of course, on new type of platforms like robots driving around in the field, or, for example, also drone flying around.
Okay.
And maybe we can imagine doing something from space as well. But
very good. We have some of them here today. Maybe we can, Thomas from Aerolaser. Hola, Thomas, ¿cómo estás? Okay, I think we have you muted. I can try to unmute you. Okay, now you can talk.
Okay.
Hello,
and I'm Thomas from Aerolaser. We are our company is in Spain, in Canary Islands, of course, with good weather. We job too, but only sometimes. We are specialists like integrator for LIDAR and camera systems. Normally, our specialist job is for power lines inspections, but we have our own production of sensors. Nowadays, we are developing our best project we are working is in our own LIDAR system. At this moment, we are working for over 1 kilometer distance for LIDAR, high frequency. And in a short time, we're working in a 4 kilometers distance for LIDAR for airplanes wrecks, for example. This is in general, where we do.
And have you been thinking about using other kind of technologies to put in your drones, such as a hyperspectral?
Yes, we're working in airplanes, in helicopters, or in drones. We have different system integrations for different airplanes or helicopters or drones. And this moment, we integrate in different platforms, but with several products, external products like cameras, LIDAR, different commercial products. But at this moment, the best project we're working is our own LIDAR. It's the high distance, high frequency. And if you want, we saw any in my computer, but in general, it's what we're doing.
Okay, so thank you very much, Thomas, for this. And let's go, well, and thank you, Christian, from SANlight, super interesting presentation. And let's go now to the next speaker. So yes, it's my pleasure to introduce you Marc Juarez from Seoul Semiconductor. Hello, Marc.
Hello everybody.
Hello, so if you want to share your screen.
Yeah, sure. So let me say thank you first to EPIC and the organization, Joseana, and all the team, Carlos also. So always a pleasure to be with you. So if you can see my screen, I will start. So the idea of, I'm from Seoul Semiconductor. I'm in charge of the technical and marketing team in Europe. And as you see, I already put here the first, in the first slide, the SANlight, because I think it's a very interesting topic for the horticulture at this moment. So I just read from Wageningen that they are looking to also simulate the sun. So I think we can have a good solution and good partnerships there. So I'm very happy to listen about it. And also I'm happy to see some of our customers already here. So really. So let's move to the next one. Just very quickly, who is Seoul Semiconductor? We are a South Korean company. We were founded in 1992. We are a family-owned company. Our revenue is $1 billion. So we produce more than 2 billion LED packages per month. So we do only LEDs, and we do all the spectrum from UV to infrared, also with the visible. So we can do everything. And we invest a lot in R&D. So this is why I like also our company. We always have something new. Then we are in we have different platforms and manufacturing centers. The biggest is in Vietnam. In 2017, we opened 100,000 square meters. So really, really big, only doing very small chips and dies. So things that are millimeters. And then going to the technology that we bring to the market is about the LED itself, that we have several solutions for all what our customers are asking. So we have customers that really want to simulate the sun, as I just heard from Wageningen and some other customers. So we have the SANlight, that we can really mimic the sun from the morning to the evening. Same blue-red ratio, red-far-red ratio is really same as the sun. And then we also have some customers that are only looking for more efficiency, micromole per joule, this micromole square meter second. So we have some other solutions. 50, 30, 30. This is the size of LED. So we have really a lot of LEDs. We can cover everything, all that you need. So then here I just want to show you some success stories with our SANlight solution. And here you can also see how it looks the spectrum. And this is also, I have always big and tough discussions here with all the scientifics because some people is only looking for the micromole per joule, 3 micromole or 4 micromole, but how about the spectrum? Because in the end, if I have a complete spectrum like the sun, I'm sure the plants will also take all the light, no? Same as the sun. So we already have some studies ongoing and some projects ongoing. So very happy with the results because they could achieve with less micromoles, with less micromole joule, same or even better results in kilograms, in taste, really, really nice. No disease, very healthy for the people working on it. So really, really nice. And then also we have some other solutions like Horticultural is a German company and they use a normal LED with extra red. This is a big trend now in the market also. And we also support this, that is more on micromole. Just to go quick. Also very important, as we are talking today about the cannabis, the association that presented before. Also happy to hear in Europe that things are progressing well. So we also have solutions for the cannabis, and we have also studies that shows much better THC and CBD contents in the cannabis when you use UV products, so UV technology. And we can supply from UVA, UVB, UVC with different types of LEDs that are easy to implement. Also, let me comment UVC now with the COVID, it was really a big boost for our company because everybody are looking also for UV disinfection. We can also support. So I hope I didn't took too much time.
You were perfect, Marc.
Perfect.
Thank you very much for being with us today. Every year in July, Marc and I meet in Munich. At this time, more or less, we will be running now in the streets of Munich together. It is a pity that the year has been so bizarre. But this is an epic event. And epic events are about collaboration. So what can you do for them? What can they do for you? The epic question.
Yeah, we are looking for cooperation with universities, with researchers that can test our technology, because in the end, we are not biologists, we are not really deep on the plant. So we are looking for people to help us test. And also we are looking for joint development. So we want to be always on the latest technology for the LED. So how can we make better LEDs in the future?
Your first question comes from an epic BFF. Mike, what's on your mind?
I'm curious about, do you have any data about your lighting increasing production of associated terpenes that related to delta-9 THC?
Yeah, so this I would share you more in detail, but we have some data about it. Yeah.
Very interested.
Yeah.
Mike, what is Photonic Insights and what is the epic answer for the epic question?
We make a low-cost spectrometer based on the AS7263, and we augment it with machine learning in order to clear up noise from the signal generated by this little spectrometer here.
Fantastic. Stealth mode is over for what I can see. Fantastic. Thank you very much, Mike. I have another question here. It's from Lima Grain. Thank you very much. What's on your mind, Pete?
Good question. I almost forgot. I'm afraid I raised my hand a bit before. So sorry, I forgot. I come back on that.
I believe your question was for the previous speaker. Could it be possible you wanted to ask SANlight? That's okay. We'll come back to you later.
Yeah, sorry. Yeah.
Any further question? When it comes to the LEDs manufacturing, you are talking directly to the end customers. I saw a lot of LinkedIn that you go directly to the horticultures and you talk about lighting with them, but you make LEDs. So there is a lot of gaps in the supply chain here. Are you looking for collaborations in micro optics, in packaging? Tell us about what we can do for you further.
Yeah, our company, we do the LED chips. So we do from the raw materials, we grow our wafers, we grow the chips itself, and then we also do the package chip. So if you are also in the industry that can supply or can help us with some improvements on the LED, we are always welcome to hear you about phosphors, also about micro optics for the package.
I can tell you one thing, Marc. Europe is now having the revolution of micro-optics manufacturing. Okay. So we had the best micro-optics worldwide, and we had the key companies in this sector developing them for automotive, for high-end lighting. I had the CEO of SUS Micro-Optics with us, Reinhard. Thank you very much for joining this beautiful afternoon from Neuchâtel.
Hello. Be with you. I'm proud today. So you can buy micro-optics, but my interest is different. Because I have lunch in the Museum for Archaeologists with the archaeology guys, and I want to have a drone which can find the Switzi. We all know the Ötzi, which was the guy died 5,000 years ago in Austria, and somebody found it by chance.
We're gonna find you a drone for that. I think we have some problem with the sound, but we're gonna find you that drone. I promise I will find you that drone. Marc, thank you very much. I'm gonna make a lot of introductions for you. It is great to have Seoul Semiconductor so engaged with EPIC, and it is great to have the SAN-like product being deployed the way that only you can do, Marc. Thank you very much for this. And we continue with the program, and we go to a company in Italy that has attracted a lot of interest from the EPIC staff, especially from the innovation manager Antonio Raspa. Thank you very much for being with us, Mattia from SANlight. The floor and the attention, everyone, is yours.
Hi everybody.
You should notice that the clothes that Mattia is wearing is because he's in a greenhouse right now. Is that correct?
Yes. Today I am in the most important greenhouse, the research greenhouse for cannabis in Italy.
Fantastic.
And, I have no time to go around, but I can show you a lot of interesting places if you want, but there are also in my presentation.
We are equally interested in the greenhouse, so you want to get up with the camera and walk around and showing us around, that's also okay. Yes, let's do that. Keep talking so we can hear you and we can see at the same time. This is what we call epic. We're going to see the greenhouse.
Just a second. I was speaking with my colleague.
I'm gonna ask my team if they can spotlight. Thank you. This is how we would do it. So what are we looking at?
Now we are in this is a company very close to the University of Bologna, where since 5 years, I think, more or less, we started to do a lot of research on cannabis because it was not possible at the University of Bologna due to some problem with plants. Anyway, now in the last 2-3 years, they became, after many years of research, the most important producer of low THC cannabis in Italy. 3 components of my research group work here, and they 1 PhD like me, and 2 master students.
Can you turn the laptop around? What do we see? You turn it around. Oh, we're still in the boxing area. We are approaching the greenhouse, I guess.
Yeah, because it's very big. This is a company that has a 30 years old, called Anubias. They are one of the most important producers of aquatic plant, ornamental aquatic plant in the world. If you are going to look at Anubias online, I think that you can find some specification. This is the cannabis area.
Wow.
This is the cannabis area. Now is you can see.
We can see the plants and the lighting. Yes.
Yeah, you can see plants. We are testing many different spectra, changing the blue and red ratio for red, UV, and also some lamps with the full spectrum that are the last generation lamps of SANlight, because we saw that thanks to the full spectrum, it's possible to increase the sugar content and some important metabolite that increase the quality of the plant.
So when we look at the plants, we can see that the lighting comes from the top. Is there any spectrometers, any sensors that you have there as well?
Yeah, of course. Here involving in this area, there are 5 different groups of the University of Bologna. Here you can see the last generation lamp. For example, obviously we are testing again the HPS. This is our standard. In this case, in the control, there are 8 HPS 450 watts, so 3,600 watts in the control. And in this table, there are only 3 lamps 600 watts, full spectrum with the power red, etc., etc. And the consumption in this table is 1,800, so more or less the half.
Oh, wow.
This is one of the most important results that we achieved. And here there are some customers that arrived from Israel, South Africa, Australia, US, a lot of customers that come from US.
Could you tell us also about the environmental monitoring needs inside the greenhouse? Do you need to control gas? Do you need to control CO2?
Yeah, we control everything. I was telling you this before. I come back in my office because...
Yes, let's go back. But that was fascinating. I'm amazed. I think everyone will remember this epic meeting forever. You made this meeting truly, truly epic.
There are also other places, but with the mothers and the cuttings, etc. But now it's too far from to arrive working.
While our friend is walking back to his workstation, are there any questions for Mattia?
Okay. Now I can hear you again. Can you hear me?
Yes, we can hear you loud and clear. I think everybody has the eyes wide open. Everybody is fascinated with what we just saw.
Yeah, here there are also the indoor area. Indoor area for vertical farming of cannabis and other experimental area. We collaborate a little bit with the ESA, International European Space Agency, because we work a lot also with the CNR, Center of National Researches in Italy. And so I am a researcher.
Fantastic.
I am a plant physiologist, academic researcher, so we do a lot of research.
We have a question for you coming from Ophir, from Bram.
Yeah, what kind of, are you using different light for the vegetative stage and the flowering stage? And what kind of light levels are you using?
Yes, we have. We started a lot of years ago, in 2004. We started in 2004 to study different light spectra for different phenological stages, like seedling, cuttings, vegetative phase, and flowering. We change a little bit the blue, red, white, and infrared ratio depending by the phase. In the last 2 years, we developed a specific lamp that can help us to grow with the same light, dimmable light in intensity, both the vegetative and flowering phase. This is very important because it can reduce a lot increase the efficiency of the area, because some growers don't know very well if they change a little bit the spaces. It was a problem. It was a problem because when we do turnkey projects, the customer doesn't know very well if the same area is always dedicated to vegetative or flowering, and if there is a little bit of changing in the surfaces. We saw that working on DLI, daily light integral, is possible to change flowering and vegetative depending by the phases. And so we use only one lamp for the both, especially if we work in aeroponic condition, because the vegetative phase in aeroponic condition is reduced so much.
Mattia, we have a lot of questions for you. I'm going to go now to an entrepreneur in the room. He's in a stealth mode, so he's using TUI in Doven as an affiliation. Morangelo, what's on your mind?
Hi, everybody. It's a pleasure to be here today. I have a question for you. Is there interest in measuring properties of plants or cannabis via spectroscopy? And how do you right now measure that? Do you use chromatography? So, for example, THC level. How do you do that?
We do a lot of analysis. I was telling you this before. 5 different groups of the University of Bologna, especially biology and agronomy department, are involved here. We do electrophoresis analysis to understand the content of some metabolites. We analyze the nitrogen content and some other microelement content with direct and indirect analysis, more or less a couple of times per week. And as plant physiologist, now I'm so much concentrated in the metabolite inside the tissues to understand the performance of different light spectra. But if you are interested, you can contact me. I can give you a lot of different kind of measurement that we do.
Mattia, we are all gonna come to visit you, just so you know. We already have marking our calendars, and me are coming a couple of weeks there. I have another question.
We are in Bologna.
Oh, fantastic. I have another question coming from Senorics. I think it's a very similar question, actually.
Yes, actually, it was quite similar because I mean, I will give my presentation later, but we have a very small spectrometer, and the question is also you need to measure every once in a while. You mentioned a couple of times per week. You need to mention what's inside, and maybe we can help in this respect.
Mattia, you didn't have a chance to share the slides, but I'm going to send them to all the participants. But what you gave them is an amazing experience that they're going to remember for a long time. Grazie mille. Thank you very much for this. I don't know how to say this. This has been truly epic. The best presentation of the 39 online technology meetings. We continue with the program now. I have a big smile. I cannot avoid it. I go to Berlin. I go to Optec, baby. I don't know you can top this. Janina, the floor and the attention of everyone is yours.
Thank you very much. I'm glad to be here. I'm sorry I will not make a tour through my apartment. I think it's not so much interesting for you. Anyway, I will start with my presentation and just to show you, wait, doesn't work? Yes. Who we are. So Optec BB, it's like a competence network of optical technologies here in Berlin and Brandenburg. So we are concentrating on the capital region of Germany. And this is an initiative of companies and research institutes here in Berlin and Brandenburg. And they made themselves, or they founded themselves on 2000 and has been supported by the Berlin Senate. But now we are supporting us. We are about 120 institute in the members now. We have, as I said, we have institutes, we have companies, bigger and smaller companies, and we are working together with the university. We are part in Germany of Optec, and we are also a member of AIPH and from Go Cluster. And now, why we are starting with Agri-photonics. Myself, I have a background in horticulture. I studied horticulture in the Leibniz Institute for Agriculture Engineering. And during my PhD studies, I've already used spectrophotometer, and I've tested fluorescent spectroscopy to measure quality of fruits and of vegetables and also of any kind of food. And that was the reason why we joined each other and trying to figure out if it's possible to bring the two communities like agriculture, horticulture, and the photonics industry together. And the goal is, now we are focusing on the plant material, and the goal is to collect data, and this data should be knowledge-based, it should be locally adapted, and it should be also sustainable for the plant production, and we are using optical methods and any kind of photonics technologies. It's known, and you have seen already, that there are many photonics already used in agriculture, but there is still some potential to go further on, because for the moment we have seen that we have limited data generation, and usually we use only single parameters and single sensors, and we try to merge them together. So we have a limited ability for multi-dimensional approaches. And also that's the nature, the variability of biological samples is so huge, and it's so important to adapt to it, that we still need a lot of effort to improve the technology. And last but not least, the costs are relevant. So what we are doing when we are trying to bring our network together, we are looking for high resolution approaches, such as hyperspectral technologies. We really want to combine it, for example, with airborne systems or with multi-sensor data fusion. And all together, we want to use new management systems, new data management, machine learning. And the goal of it is to help the farmers, to give them better information that make it easier for them to have a more economic crop management and to make a smarter and a faster decision. The network is founded by the ZIM. ZIM is the Central Innovation Program for Small and Medium-Sized Enterprises here in Germany. And it's launched by the Federal Ministry for Economic Affairs and Energy. And this program allowed us to bring people from international people and Germany together. And in this case, we almost needed at least 4 SMEs from Germany and 2 international SMEs. And we can also work together with research institute and technology organizations. And this funding program is split into 2 steps. We are in the first 1.5 years. That's the beginning to make out the network and to focus on a technological roadmap, means to see who can join a project, who can collaborate together, and where we can apply for funding possibilities and which kind of project we can start. And this will be the second part of this network, the next 2 to 3 years, to focus on these projects. Actually, we are working together with Israel. That's our international ZIM network, and we call it Agri-photonics. The management, it's the Optec BD, so it's we, together with the Leibniz Institute for Agriculture Engineering and Bioeconomy, who's bringing the part of the agriculture and horticulture knowledge. And on the Israeli side, we have Photonics Israel. That's also the community or association of the photonics industries in Israel. And they are deeply working together with the Agriculture Research Organization, ARO Volcani Institute, bringing the horticulture and agriculture knowledge. just to give you an overview, that's our partners for the moment. They all agreed to be part of this network. On the left-hand side, you can see all our smaller companies working with us together in this network. It's mixed between German and Israel companies. On the right-hand side, we have all the universities and the institutes working with us together. And the three companies on the top, they are bigger or smaller companies that are not called SMEs in the definition of the EU. What are we looking for? What are we focusing on? So as I told before, we are measuring plant material. For the moment, we are not focusing on the animals, but we are covering the whole value chain, like focusing on the pre-harvest, during the harvest, and also on the post-harvest part. And when we talk about pre-harvest and harvest, we mean like orchards, like flowers and trees standing for many, many years. We are also looking on the farming part. That's completely different than the orchard part because it's changing every year. And then also greenhouses that has a different environment. But when we are looking on the post-harvest part, we are talking also about how can we use optical technologies in the sorting part, like sorting machines? How can we improve packaging by using optical technologies? Also, like monitoring the storage condition using optical technologies. And when we talk about minimal processing, that's where we made the end for this network, for this approach. We said, okay, everything that is minimally processed without any transformation, like cutting salads or cutting fruit salads, that's where we stop. And we already start to have some project ideas. I cannot tell you about the insights of these project ideas, but just to give you an overview, we have many, many ideas for the first part, for the sustainable resource saving production part. And we need more partners and we need more ideas and more different expertise also to focus on the harvest part and also on the post-harvest part. So what we are actually looking for is more partners that are interested to joining this network and to make out project with whoever they will find in this network, it's available for them. And last but not least, I will give you a kind of save the date. So we are actually organizing 2 conferences or online workshops for agriculture and photonics called Agri-photonics workshops. The first of them will be held in September 8, and it will be organized by Photonics Israel and the Agri-photonics Institute. Therefore, we are looking for companies that want to present themselves and focusing on who they are, what they can, and who they are looking for. Same for us. We are, Optic BB is organizing in the framework of the Photonic Days Berlin-Brandenburg 2020. On October 7th, we are organizing an Agri-photonic workshops where we are also looking for companies that wants to present themselves to get in touch with our and also with the bigger community, because as we can see, the big advantage of these times is that we can do and present ourselves in the virtual room and we can reach much more people than before. And it's much more international than we can do if we want them to come to our place.
I fully agree, Janina. Actually, I do believe that the online meetings have the potential of being 100 times better than the present meetings. Also, not because we had the chance of being this afternoon in 1 hour, because we're going to finish on time, in 1 hour being with our families, but also because we just saw a greenhouse inside from cannabis. I think there are still questions. I think I'm going to go now back to Seoul Semiconductor. I think you had a question, right?
Yes, Jose, thank you. So thank you, Mattia. I could speak for 1 hour with you, I think now, because many questions come. But what I've seen from your greenhouse is that you have a direct sunlight, correct? So you are receiving the sun and then you are supplementing the plants. Is it like this?
In that area, yes.
Okay.
Half of the glass, or half of the roof is covered by sunlight. Okay. Anyway, we have a completely shadowing system to create a completely dark solution in order to push between 4 and 6 times per year the flowering.
And my idea was, do you have some research without the sun? So what would be the best spectrum for the plant when there is no natural light? When it's only artificial light, what is the best for the cannabis?
Yeah, this is the this is the point of the spectrum, because I started to work only recently in the last 4 years on cannabis, but I always worked on vegetables. And now with SILED and Cefla Group, we do more or less that 99%. Cannabis is only a small business, very interesting, but only a small business.
Yeah.
If we work in integration with the SANlight, I always saw that only blue, red, and a little sometime also for red are enough.
Mm-hmm.
If we work in indoor, it's really important to give a full spectrum using also outside PAR wavelengths like UVA, B, infrared.
Mm-hmm.
Green and yellow wavelengths are very important for sugar and antioxidant content. As plant physiologists, this is the topic, because not only the quantity of food, but the quality. So the nutraceutical compounds are driven by that kind of wavelength. So we are working on that so much.
So open to collaboration with all the researchers. If you can test our LEDs, more than happy to
yeah, why not?
No
Yeah,
problem.
Absolutely.
Sure. We keep in touch.
Okay.
Thank you.
Okay, thank you very much. Yes, I hope that there are going to be a lot of connections with you, I think. So let's come back to Janina, because Janina, you mentioned a lot of different applications for photonics in agriculture. But if you think about the projects in which you are working, what will be the perfect company for collaborating? This company will be developing laser light sources, or will be developing sensors. So what is like the weak part that you see, in which we can support you?
Yes, actually, we are always looking for new components, much cheaper components, much faster components, and easy to integrate. And we also need, but it's to bring them together. So we need a lot work done for data acquisition and data management afterwards. So that's the challenge in between. First part, make it easier, bigger, cheaper, and the other part to bring the data together.
Okay, very good. So if any of the companies in the room can do it cheaper, faster, and more efficiently, please, we will put you in touch. Okay, and now maybe I can find a keynote for you for the agriculture conference that in which you are participating, because we have here Martin from John Deere. I don't know, Martin, if we already fixed our sound problems. I hope yes, because you are one of the important end users.
So.
Yes. Sure. So, well, John Deere, I am super impressed, almost as impressed that with the cannabis plantation, because we have here, I mean, you are a manufacturer of trucks, and my son has some kind of toy, with with this brand. So, can you explain us what are the technologies in which you are interested for this application?
Actually, we are using technology like this in many areas. We have different types of sensors that are actually mounted on the machines for proximity sensing. This starts from guidance support system to material sensing portion. Within the harvesting material goes along with the application of pesticides or plant protection agencies in the field to optimize the amount that is applied, and ends really in the satellite data sensing area, so in the remote sensing area. So we have a complete spectrum, and I'm impressed to see on how many different things are actually covered by all these companies.
Thank you very much for this. So are you looking for any specific need or collaboration here?
Actually, I'm always open to look into any type of collaborations. I think the idea is to see what is ongoing in the marketplace, what could be done, where are the opportunities. And I'm, as I said, really impressed to see on how many things are there. I have quite some ideas taken along here and took some notes. So I'm looking forward to talk to the one or the other company, not specifying this yet in detail, because I think there is also some IP here involved, and we'll see on how it goes. So that's a great event, and many thanks for inviting me.
Thank you very much. I mean, we will be super happy to put you in contact with any of our companies, and I hope to see you in many other events related to agriculture and environmental. Okay.
I will keep an eye on it.
Thank you. Okay, so if we don't have more questions or more comments for Janina or for John Deere, then we will move to the next talk. So yes, it's my pleasure to introduce Matthew Hagen from Gamaya.
Hello.
Hello, Matthew. So thank you very much for being here today. And please, well, if you want to share your screen.
Yes, of course. Hello, everybody. Thank you very much, Anna. Thank you, Jose, for your enthusiasm. It's the first time I participate to this event. Can you see my screen already?
Yes.
I can see some movements.
Yes, now it's perfect.
I'm going to present Gamaya. I was not expecting such an expertise in agri-photonics and optoelectronics, which is my background, by the way. So I'm quite impressed. We, Gamaya, are aiming to use artificial intelligence and patented hyperspectral cameras to bring solutions to farmers. So we are quite linked to, quite close to John Deere in a way, but a little bit in Actech as well. I will show you in the first slide here. This is more or less a complete offering of Gamaya in a synthesis. So the first block is about the advanced analytics. So we bring analytics in different crops worldwide. Our customers are mainly in Brazil, India, and USA. We work in sugarcane, soybean, wine, forestry, corn, wheat, citrus, just to give you an overview. And our main partner for research are in Europe. So the analytics are based on remote sensing imagery from satellite, airplanes, and drones. It could be RGB, multispectral, and hyperspectral. When it comes to hyperspectral, we decided 5 years ago to start, when we started the company, to build our own sensors and our own cameras, which we patented. So it's a mosaic type of sensors based on nanotechnologies built in Belgium, you may think about it. And quite unique to identify phenotyping elements, senescence, nutrition as well, NPK deficiency. Citrus greening is also one of the topics we work on, herbicide efficiency, these kind of elements. So we, as I mentioned, take the imagery from satellite, airplane, drones. All the idea for us is to capture as much ground truth as possible, sometimes to solve problems at the ground level with drones, or to scale up to satellite as much as possible, meaning that we need, of course, to have a lot of analytics behind that, based on crop models, spectral signature databases, and we've built our own analytics for pre-processing and as well, to bring information to the farmers to manage their crops, so crop monitoring, anomaly detection at a large scale level, or bring analytics to drive sprayers or drones to reduce the use of fertilizer or herbicide, for example, or to embed our analytics into tractors, sorry, I'm going back, into tractors or machineries to drive them properly through the fields to harvest and avoid trampling, for example, which is a huge problem, for example, in sugarcane. One of the example of use case is we may have one of the crop like soybean, which has a problem of nematodes in South America, and in this specific use case, we develop an analytic. To roll out the analytic worldwide is, of course, another story. We need to start again, to build ground, to capture ground truth, etc. And we do all this work with partners, so large partners from the industry, of course, when it comes to commercialization. But when it's about HSI, so hyperspectral, we are looking for partners worldwide, but research center to use the cameras to solve problems by farms or others. So these are some of the products we have. For the sugarcane is an example based on our analytics. So it could be from drones, the planting gaps, so all the area which are not planted. So we detect these, we can check the percentage and determine some actions, or we can determine the weeds, for example. And now more and more the class of weeds, and in the future, the very specific species of weeds, meaning that we will know also what kind of herbicide is needed in which area, in which quantities. Weed infestation monitoring from satellite is very useful to monitor for large domains. US, Brazil are obvious in this case. Precision harvest line, just as I mentioned, to avoid trembling, for example. And then we have the crop monitoring and anomaly detection, which we use not only in sugarcane, but wine as well, soybean. This is quite critical when it comes to manage large farms. I took some examples because we are here in Agri-photonics by EPIC. I took some examples of project run with a hyperspectral on nematodes, for example, field trial evaluation. That was in Switzerland. We work very much with ETH in Switzerland, with agroscope, NPK nutrient deficiency, citrus greening, for example, disease are some examples. And I just took some elements of the very new generation camera, which we are building right now, and we will launch next month at a research level, a prototype level just for us, and we may launch, build some additional series by the end of the year for research use. So just to explain that we have this very specific mosaic technology, enabling us to have these lightweight cameras on drones, which is perfectly useful for research. That was my pitch.
Thank you very much for a fantastic pitch. Gamaya is truly fascinating technology. This is quite impressive. This is an EPIC event. EPIC event is about collaboration, and you know the EPIC question. Do you have an answer? Mattia, what can you do for them? What can they do for you?
Oh, sorry. What can you do for me is we are looking for partners and research centers worldwide to solve problems with the cameras, with the lightweight cameras we have developed. We are also looking for hyperspectral sounding board that could support us in the development of future sensors. And joint development is definitely the way we want to develop ourselves in the research for hyperspectral, not speaking about commercial, which is kind of an obvious one.
We have a few questions for you. The first question comes from John Deere. Martin, goedemiddag. What's in your mind?
Oh, yeah, Mathieu, I think that was a very interesting presentation. Many thanks for that. I'm looking more from the end user, from the end customer perspective at your presentation. I was wondering whether you're actually providing some type of portal, some kind of interface to the end user to actually work with the data that you're generating out of your camera data and your AI.
Thank you for the question, Goeiedag. Yes, indeed, we do have a platform. We provide a full end-to-end user interface. So all the data we have from satellite, drone, and hyperspectral are computed with our computing processing, so processing pipeline, and we provide the user interface and the visual management. This is something we should keep in contact, Martin, for us to do a quick demo to you.
That would be perfect. That was, I just wanted to mention, we are the right persons to talk to each other, I guess, because we can provide your platform to exchange those data with our system.
And by working together, you make the meeting epic. And the second question comes from Lima Grain. Pete, what's on your mind?
Sorry, yep. Can you hear me?
Yes, loud and clear.
So I was wondering, so if I saw correctly, your sensors are ranging up to 1,000 nanometers or something. Do you also develop sensors up to 1,700 nanometers or further from this lightweight type?
So the answer is no. I think we go, well, for the moment, we go from 450 to 900. This has been the range which we consider as most useful in all cases. And the idea for us, depending on the use cases we will have in front of us, will be to develop together with our partner, which I can mention here is IMEC in Belgium, in Leuven, to develop other sensors with other bands. So this is definitely, for the moment, we have two sensors, 42 bands and 31 bands in vis and near, as you mentioned just before.
Fantastic. And we have two partners for you here in the room, the two potential partners. The first one is here with me in the Netherlands, Demcon. Gerjan, goedemiddag. What can you do with Mathieu?
Sorry, can you please repeat the question?
What kind of collaboration do you think Demcon and Gamaya could have?
Well, we have quite some, let's say, quite some artificial intelligence knowledge, and we really know how to, let's say, process, let's say, quite some stacks of data. I'm not sure whether that is kind of relevant for processing all the imaging and all the stuff.
So, Gerjan, thank you very much. I was lucky enough to invite to this meeting some of my colleagues, including Thibaut and William and Samuel. These are my experts in this domain, but to answer very directly to you, yes, there is a need to collaborate. There is a need to have sounding boards. There is a need for us to expand the knowledge.
Another potential partnership here. Great, Gerjan, you have to be happy with Epic because, you know, I want you to be here for many years. And the next one, I'm going to go to Spain. I'm going to go to Smart Hubs because they also want to work with Gamaya. Luis, ¿cómo estás? How are you doing today?
Fine, thank you, Jose. We are looking for, we are developing our own high altitude platform system for remote sensing applications. And one of our key areas is agriculture monitoring. So we are looking for partners like Gamaya for payload development and also applications development in this sector. We have already discussed with some potential customers, and we are looking for partnerships.
It is quite an outstanding technology, the one that the Smart Hubs is doing with these fantastic planes. What kind of cooperations do you think you can have in the realm of agriculture?
We still need to develop payloads. I mean, there are some potential systems in the market, but we have to tailor hyperspectral and multispectral payloads for our platform, and also to define the whole data chain for our system. And application in agriculture for very wide areas is one of our targets.
I show here in the previous, in my discussions with Cesar, the amazing hubs that you are making. And it's great that you consider your photonics, as it was said before, a candy store. I love that expression. Yeah. Luis, muchas gracias. Thank you very much. This is an epic meeting, and I enjoy it so much. I don't want it to finish. We still have 45 minutes to enjoy, and we go to the next presenter today. We go to an amazing company that I'm really happy to have today because they are raising so much interest in the field of spectroscopy, taking spectroscopy to the next level. Christian from Senorics, the floor and the attention of everyone is yours.
Thank you, Jose. And first of all, I would like to thank you and your colleagues and Anna and whoever is busy with all these meetings. It's really amazing what you have set up in this crazy bizarre, as you called it, times. To bring all the people together, despite that we cannot meet in person, but it's really amazing. So thank you, and also for the possibility to speak today. Senorics is quite fresh, 3 years old startup company, not small anymore. We are already 40 people, or close to 40 people. And our topic is mobile and low-cost material sensing solutions. What I mean with the sensing solutions or material sensing, I brought just 3 examples, not all from the agriculture, but just one. So these are just examples. We can identify fabrics with our technology to set the laundry settings, or detect coolant composition to see when it's exchanged, or which is the topic of today, measure the level of moisture and proteins, for example, in crops, to tell the farmer when they could harvest. But this is only some examples, and we're not developing the examples, but the solutions. And the solution which we have is a spectroscopy on-chip technology, which is based on organic electronics. And the core technology which you see is on the top right. So this is our chip, which we developed. And this chip is basically the full spectrometer. It does not need any optical pathways or diffraction gratings or diffraction optics. And that's why it can be low cost. So we want to reduce the prices of this technology down to a few dollars per chip when it's scaled up. It's material manufacturing because it's based on the same technology as OLED, and that has increased over the last years in the TV sector. It can be very small and robust, and also still exact, because it does not have these the diffraction optics. And we still cover a broad spectral range. So we can do from 450 up to 2000 nanometers, which allows a broad range of applications. But it's not only the hardware. I mean, most of the people in the room probably know, and this slide is for those who don't know. What you still need when you do spectroscopy is some chemometrics, which is to translate the spectral information to some useful information which you want to have. This is just the example to explain it from the textiles. So, for example, when you want to identify which textile you have in the washing machine, you do a spectral measurement, but then you only have a spectrum. So you don't know which type of textile it is. And you need to do a calculation with a model, which is basically a calibration model. And then this model will tell you, so this one is wool, this one is silk, and this one is cotton. That's also a kind of service which we offer. So this is our material sensing platform, how we call it, and it's basically our offer. So we start with the development, which means when we have a partner that comes to us with a problem and says, "I would like to measure this or that," then we can help this partner with an evaluation kit, so which is basically hardware. With software, which is the calibration, and also some other services to develop this model, which you need for the translation. And as soon as we have that, we know that we can fulfill the requirements, that we can solve the problem, and we can measure what the customer wants. And then we can go to the next phase and ship out our hardware to our customers to make the product that can go to the end customer for this application case. And finally, as soon as the end customer has the full hardware at hand, then we also offer cloud services to exchange the raw data for the real information which the end customer needs. So that was already very quick. I'm already at the last slide, and I'm sorry, Jose, I already included the epic question in the summary slide. So the summary of what we offer is we offer the full toolbox solution for the problems in the world, basically. So we offer the hardware, so we can supply the hardware, which is a very, very small, very unique, low-cost spectroscopy solution. But we also offer measurements to get started. If you do not have any experience with spectroscopy, we can help with this also. We offer the hardware and also further engineering and also software data handling, so the full toolbox to get you started with spectroscopy. And the other side, what we need is we need use cases. We need the problems and we need the challenges. Because we're a technology company, and we cannot even imagine which problems are out there, which we could solve. And we also need the system integrators, because will be difficult for us to get directly to the end customers. So that's why we are mainly searching for system integrators, people who know the customers, who know the problems, and can integrate our spectroscopy solution in their products. So that is the main thing which we need. And the other thing, which I have on the top right, we're always open for EU-funded projects, which is always a good opportunity to get in touch and develop something together. We have one running, which is the Multiple project, which is about multimodal and hyperspectral sensing solutions, different fields. There's also food included. In this case, it's chocolate. Yeah, so if you have any idea, any projects where you think we could contribute, then we would be happy if you would approach us. So that's the final point. Let us help you to bring spectroscopy into everyday lives. Thank you.
Thank you very much, Christian. Super interesting presentation. So, well, you already answered it. What are you looking for? So, well, maybe we have here already one end user, one system integrator that is interested. So, Piet from Lima Grind, would you like to make your question to Christian?
Sorry, there we go. Hello, Christian. How many wavelengths are you measuring, and what is then also your wavelength precision?
So we are at the moment measuring 16 wavelengths. So on the chip, which I've shown in the presentation, there's 16 single pixels. So we have 16 wavelengths, which we can measure at the moment. In our standard, which we have, it's between 1,100 and roughly 1,900. But there's no technological constraints, so we can increase that. But from our experience with the use cases which we had up to now, we saw that for many, many applications, you do not need the full spectrum to get the information which you want. Of course, there's much more information in the full spectrum, and you can do a lot more with the full spectrum. But if there's a concrete question which you want to ask, then 16 channels are, in our experience, for many use cases already enough.
And so what do you mostly, is the wavelength distance or the distance between the different chips, is that fixed, or can you choose the wavelengths?
It's not fixed. In theory, you can freely choose, which makes it a little more complicated. But to make slight variations, to have, for example, like some channels close together, that is easily possible, I guess.
Okay, I see. And from your experience and applications that you tried so far, where are the differences in what is feasible, what is not feasible, if you compare your technology now to more high-class laboratory instruments or more high-resolution instruments?
I mean, of course, there's always something you have to sacrifice. So if we compare to a lab spectrometer, of course, the first thing which we sacrifice is the channels. So we have only 16, so not a 1 nanometer resolution. But as I mentioned, if you just want to know a specific thing, and that's in most use cases, that's the case, then the 16 channels are enough. The other thing which we are sacrificing is, of course, a little bit of accuracy. So if we talk about classification, so whether you want to know whether something's inside or not, or to distinguish between different objects, this is usually easy. If you want to do quantification, then it's a specific matter of the application. So usually if you want to know something percentage inside, if you're talking about percent, it's usually doable. If it's below percent, then it's it depends on the application. PPM is usually difficult.
Okay, thank you very much. This is a very interesting discussion. Now I would like to, well, maybe it's the good moment for one of your colleagues to comment. We have here Alejandro from Iris, and they are also in Barcelona, right? Very nearby me. Alejandro, are you here?
Yes, I am.
Hello, Alejandro. How are you doing? ¿Todo bien?
Hello.
Would you like
Muy
to
bien,
comment now what is it is doing in the in the near infrared spectroscopy and hyperspectral?
Yes, and I think it's a good point. I totally agree with you because, in fact, we are in conversation with Senorics. I think we held a meeting 1 week ago, more or less. Okay, so we were discussing the possibility to apply their devices or their sensors in our solutions because of the price, mainly because of the price. As Christian said, obviously, in some cases you have to sacrifice. You cannot have it all, okay? But in many cases, you only need information from a specific band with the spectral range, and this is ideal. This situation is ideal for this type of sensors. We integrate sensors, spectroscopic sensors, to develop solutions, generic solutions, all in one. I mean, turnkey solutions for the industrial environment. Okay, what is intended for monitoring industrial processes. Okay, today I'm here just to know what's happening in the in this sector, in the agricultural sector. Just to know the possibility to extend our current scope to this sector, because we are mainly working for the industrial sector, but in any case, farming is part of the industrial sector. From our point of view, farming currently is not a matter of picking by hand things. It's just applying high tech for improving the efficiency, for having highest quality. And this is a good example. I mean, the Senoric and the Iris potential relationship, and this is more or less what we are looking for from this type of meetings. Not only knowing what the market needs, obviously we are interested on that, but also knowing the potential providers of novel solutions like Senorics. Okay.
Okay, thank you very much, Alejandro. And if you think that you could make this kind of partnership with any other company in the room, just ask us and we will contact with them, okay? Okay, and now also we have from Hofer CAP that has a question. David, are you here?
Yeah, I was going to ask Christian, a really interesting technology, and in a previous part of my career, I worked on milk analysis in some difficult conditions, looking for adulteration, fat content. Is your sensing technology applicable in liquid samples?
Yes, it is. So we have already developed two solutions. One is for the solid samples, where we measure inflection, and one is for liquid samples, where we usually measure in transflectance. So usually, if there's no specialty in the liquid, it should be doable. I mean, milk is not so easy because it's so much inside, but that's a measure of the chemometrics, I would say, and not of the sensor.
Yeah, I think chemometrics is a useful technique for milk anyway, from a past experience. So I think there might be something there for you.
Okay, great.
Okay, Christian, and we also have, you cannot leave yet, we also have a question from John Deere. Martin, would you like to make the question? Hello, Martin. Okay, so, well, in fact, I cannot see him yet. Okay,
Excuse me. I was just asking whether you hear me. I saw you wondering, so sorry about that. So, Christian, many thanks for your presentation. I think that was great. My question goes a little bit in the same direction as the of David. We are mostly working in very rough conditions. So do you have experiences also in rough conditions and ruggedized build-outs of your sensor?
So I guess you're asking concerning such machines which I see in the background, like harvesters and so on, where you have a lot of dust and vibrations and so on. To be honest, we have not yet tested in such environments, at least not live tests. But I could imagine that as the spectroscopy, which we do, is done on the chip itself. So at least it should be much more robust than a typical spectrometer. That would be my guess. But
no, the question is very clear. Can you send some devices to test it at the machinery of John Deere?
From us, it's not a problem.
Fantastic. There you go. Back to Anna.
Thanks.
Okay, so that is very, very nice. Okay, so now we can, there are more questions, more comments. Okay, so if not, let's move ahead in the program. So after this fantastic presentation from Senorics, thank you, Christian. We go to TU Eindhoven, all the way to Eindhoven, and we are going to talk with Marangelo Petrusella. So Marangelo, if you would like to, yes, very good. And now you can go to presentation mode. Okay, very good. The floor is yours.
Hi, everybody. Thanks again for inviting me here. It is a pleasure to be here. And well, I'm currently a researcher in the Eindhoven University of Technology. And actually, I'm here to talk about something that we have recently developed. Well, you see already some concepts are similar to what has been presented in the previous session. We're talking about spectral sensor. We're talking about the next level near-infrared spectral sensor, in particular for agri-food application. There is here a picture of one of the sensors that we've been developing in the past years. It's based on a multi-pixel array. And the concept is the following. We have several pixels. Each pixel has a certain spectral response in the sphere, so in the short wavelength infrared region. And then after shining, for example, a tomato, we can just measure the reflectance from a tomato. And from the photocurrent of this array, we can actually access the properties of the tomato. So we just use light to measure properties of materials. I'm here today because, this technology has been developed in the past years at the Eindhoven University of Technology, and now it's we're ready to spin off this technology. It will be commercialized by a spin-off called Multispectra. Eventually, it will be the 600th member of AIPH, I hope. It is based on a hybrid platform. So it is based on a semiconductor material. In particular, it is based on InGaAs bonded on silicon. And here you can see one of the wafers that we produce at our own facility in our clean room, where we actually integrate the detectors and the filters at the wafer level. Importantly, we can actually tune the response of the detectors in one lithographic step. This is something that we believe is quite cool, because actually we can have different chips with different customizable, let's say, performances for different several applications. So in general, this will also decrease the final cost of our devices. Again, we work in the near infrared, actually in a wavelength spanning from 800 to roughly 1700 nanometer. And importantly, we have high responsivity. So you do not need to use very high power lamp to measure your properties. So no heating involved. We measure high responsivity about 0.28 ampere per volt. So this means that we can use microwatts as power. And again, it is a easy readout and customizable. So we have been optimizing this technology again in the past years, but also we started thinking at the commercial side. And of course, you don't want only to provide chips, but you need to provide some viable solution, some demonstrator to people so that they can play with it. So we also started developing a standalone module, which includes an optic module, so a simple lens assembly with illumination system, but also a readout electronics where actually we can just connect, our electronic board via USB and read out these 16, 15 photocurrent measurements. And now actually we are experimenting with this device. So we are really into the, let's say, hacking mode, in which we are experimenting with different applications, very different applications. Many of these applications are actually in the agro world. So just showing here a couple of applications that we are playing a bit around. Here you can see well, at first prototype of our device. It's even smaller than a cherry tomatoes. At the moment, here the electronic is done outside. But at the same time, we have been measuring liquids. It was really just in the previous question, can you measure liquids? Well, yeah, I mean, we are playing with liquids. In particular, we're measuring milk. And as you can see here, just by using some chemometrics on this simplified spectrometer, we are able also to measure the fat property of milk, also with a very good accuracy, I have to say. So hopefully you will see also the results that I'm showing here in a paper that we are actually now preparing. Well, this was what, let's say, the main part of my presentation. I'll just go to the, let's say, epic questions, as you call it, and what we are looking for. So we have seen that, for example, in agri-food, many agri-food application, well, there is a bit of a gap between what you can do, or what has been done actually with the near-infrared spectroscopy and what is actually out there. So we are looking at a collaboration which we can understand the problem and at the same time develop a custom application for that particular problem. At the same time, as you can imagine, we are also looking for partnership with system integrators to develop, for example, a handheld device, but also on tractors and robots. So this is something that also we are keen to further explore. And what we can offer, well, yeah, just like, let's experiment. You can just visit us or probably send your samples in these times, and we can measure it and see actually if we can predict what you expect. At the same time, as I mentioned, we have the possibility, a platform where we can customize a module for a certain application. And this is quite powerful because this will allow us to have an hardware-based optimization. At the same time, we can support you with our spectral kit. And well, we also have expertise in building simple modeling and validation in a lab. So thank you, Lord.
Thank you very, very much. I love what you guys want to do. And those detectors from 800 to 1.6 microns, if you take them to the market, you're going to get this world by the horns. Fantastic technology. You answered the epic question very well. And we have questions for you. The first one is from Iris. Alejandro, what's on your mind?
No, yes, basically, well, it's very promising. As I mentioned before, we are particularly interested in new technologies, okay? And it looks really promising. So I have a couple of questions in relation to that. First of all, how far or near to the commercialization stage is your device currently? So what's the launching day that you foresee, and also if this type of technology has a significant advantage compared to, for example, the traditional photodiode array. Okay.
Yeah, so thanks a lot for your question. We foresee that in the coming months, a developed kit will be available. So a kit that will allow users to play with it, in particular, that will include the electronics, the chip, and the source, so that you can already start playing with it. This is for the first question. Regarding the laser, so the diodes, these are usually very expensive solutions. We are targeting here, let's say, prices very competitive, although it is based on, let's say, an expensive technology, because INCAS is expensive, but gives you, let's say, the potential to measure with low levels of light. And we are doing this really based on how we develop the technology, because again, we can actually fabricate different devices for different applications in a single run. And we can measure, in practice, we can produce thousands of devices per wafer run. So it is basically the effect of integrated photonics, but applied to, spectroscopy.
Please, when you have a chance, send me an email. I'm pretty sure that the guys will give you my details because I'm really interested on that.
There is a great place for cooperation here. We have another question from Lima Grain in Netherlands. Pete, what's on your mind?
Yeah, you answered it already partially, but you were not really very precise. So my question was, so first of all, will it be cheaper than classical diode array, and how much cheaper? Are we talking about a few hundreds of euros?
We are talking about a few hundreds of euros, correct. Below, for sure, 1,000 euro. We are targeting a price in between 500 euros for the full module. So this is our target.
Okay, sounds great. Thanks.
We have one more question, but this one is for Senorics, and it's coming from the YouTube universe. So, do you also work on developing multispectral sensing material, Chris?
Multi-sensing material in the sense of...
do you also provide... the question is for both of you, actually, for TUA and Senorics. Do you also provide the material themselves? Could you provide also the detectors?
Yeah.
Okay, yes,
Yep.
and you yes. Both of you say yes. So you're looking for a partnership here. It would be great to.
I'm not sure whether they are asking for the chip or for the active material itself in
They're
the
asking
chip.
for the active material, I believe.
So for us, the active material which is inside is part of it is our IP. So I guess we will not ship that one outside. But of course, the chip, everyone can buy our chip.
Fantastic. Another question for Senoric from Tashion. Tashion is being asking a lot of questions in the chat. So hello, Tashion. Thank you very much. I have a question for Senoric. He said, I understood your technology is based on organic layers. Very good. As well as pretty low responsivity. Are organic layers normally severely suffer from fast degradation and very low responsivity in the SWIR region? How are you going to tackle this?
That's twofold. The one is the lifetime of organic layers. This is actually not an issue anymore. It was an issue 20, 30 years ago when people started with organic electronics research. But in the meantime, we have organic solar cells and we have organic light emitting diodes, and there has been so much money and time and efforts went into this part. So that's actually, in my eyes, if you do not need special things, that's not an issue anymore. So for our sensors, this is not an issue. Sensitivity, yes, we have not the recorded sensitivities, that's true, which is in one part relying on our technology which we use. We have talked before that if you want to have benefit on one side, you have to sacrifice on another side. We sacrifice a little on the sensitivity, but again, from our experiences with the use cases which we had and the first measurements with our device, it's sufficient for most of the applications which we want to tackle.
Fantastic answer, Christian. Great job as well, Morangelo. You guys are on the money. I mean, I do believe what you are doing, the both of you, on bringing spectroscopy to the next level by miniaturization, volume production, and you didn't say, but I can say, cost effectiveness. Really, really great job, both of you. These deep tech technologies are really positioning Europe at the lead. And anything that you do for these two guys, you're doing for EPIC as well. So anybody who wants to cooperate with these people, please do. Senorics has raised a lot of capital and interest worldwide, and I want the same to happen to Morangelo. I'm going to stay in the Netherlands now because I love it. Great country. And I'm going to go to Avantes. I'm going to go to Gerd. Thank you very much for being with us. The floor and the attention of everyone goes to your spectrometers.
Okay, so I'm seeing if I can put my presentation on the screen.
You
Good
did
afternoon,
great.
everyone. Let me see. Is it presenting to everyone?
I think you are, yes, no, you are sharing the wrong slide. You are sharing the wrong slide. So you have two screens in front of you. So just go to Verhaving's, perfect.
Yes,
No,
like this? Okay.
Yes, now it's good. The floor is yours.
Okay, thank you. And hopefully everybody stays awake. We have a lot of time beyond us, but everybody is still energetic. And thank you for tuning in to my part of the session. So I'll start right away and tell a little bit about Avantes. My name is Gerloop. I'm product manager at Avantes. To give you an idea about Avantes, we develop and manufacture compact spectrometers, fiber coupled, light sources, fiber optics, and accessories. We do that, to give you an idea of the size, with about 85 people in Apeldoorn in the Netherlands is our headquarters. Worldwide, we do that with about 110 people. So we have sales offices in the Netherlands, in the United States, China, and Germany. And for the rest of the world, we get help of a wide distributor network, about 44 distributors in it. To give you an idea how present we are in the world, so far we have sold about 50,000 spectrometers into the world. Luckily, we make some money with that, which we can reinvest to make new spectrometers. And we are part of the Dynamic group. So if there are projects and groups, things we cannot tackle ourselves and help you with, we have also sisters in our company which can take on bigger projects. What do we do? Our core business are spectrometers, and then we are looking in the classical way of spectrometers based on the Cherney-Turner with gratings. So fiber optic light gets coupled in, gets shaped so that a dispersive element can split it up in all the wavelength, which will be projected on the detector, a line array, so that produces a signal to be analyzed. And in that we have created multiple series of spectrometers, our compact line, which are very small compact spectrometers, very ideal to be integrated into handheld devices, a trend which is really can be seen. The Star line, our most standard and highly configurable line of spectrometers. And for the more demanding applications, like fruit sorting and things like that, where back-thin cooled spectrometers are needed, we have the Sense line. With these, we cover about the range between 200 and 1100 nanometers, but with the in-gas detectors used in the NIR line, we can cover up to 2500 nanometers. Also, the Sense line and the NIR line are very popular spectrometers in the agriculture and the horticulture field. Of course, a lot of people, when we talk about spectroscopy, a lot of technologies and principles come into place, from UV-Vis to NIR to Raman technology, laser-induced breakdown spectroscopy. But in agriculture, often absorption and transmission and reflection and fluorescence is very important. So there are a lot of fields spectroscopy can play a role in, and therefore our spectrometers. So I gathered 4 application examples from this field to give you an idea where our spectrometers are used. So NIR spectrometers used in a very rigidized housing to put on harvesters. So maybe John Deere is interested in this, to analyze during the harvest online the corn, the grass, or the alfalfa, and takes parameters like dry matter, raw fiber, raw protein. Another example, testing manure, in plain English, analyzing the shit. So that can either be done mobile or stationary. So by creating a device where light is put onto the ground and the reflection is measured, we can determine what is absorbed by an NIR spectrometer, and analyzing that data with chemometrics, one can take out the parameters like dry matter, nitrogen, phosphate, or potassium. Third application certainly looks familiar. I saw lights like this in the cannabis, on seabed and things like that. It is obvious that when you do these greenhouses, glass houses, and this LED way of growing, the light needs to be analyzed. The UV part needs to be determined, the PAR, the infrared, so that the light recipes can be observed and analyzed so that it can be optimized for the plant growth. Also for this, one needs spectrometers to see what light is hitting the grass, the plants. And the last example is in fruit sorting. With NIR, so in the region between 700 and 1100 nanometers, it's a great region to detect the sugar content and even look beyond the skin for rotten spots. And doing that in the fruit sorters, you need high sensitivity, high speed spectrometers to analyze that. just 4 of the applications related to the agriculture and the horticulture field. So here's your question, Rosé. I included the slide for it. We offer spectrometers, fiber optics, light source and accessory software. So these are the components, but also support and within Avantis, years of application knowledge and experience. What are we looking for? Actually, we are looking for these companies and companies like system integrators or the bigger end users who want to add value to these products together with us to offer a solution to the agriculture and the horticulture market. And with that, I believe I am within the 6 minutes I was given.
Yes, sure. Thank you very much, Gerd, for this super nice presentation. Okay, you already said what are you looking for. So let's say, well, let's put the question another way. What will be the perfect end users for you to work with?
Perfect end users would be the bigger OEM, original equipment manufacturer, who want to integrate our spectrometers and other products into their end product. We are not looking to create a final solution ourselves. We want to help, take John Deere's, they have a problem and they want to create a solution for it. And we have the expertise to translate their needs into spectroscopy needs and fit the right rigidized spectrometer to it. So we are looking to get into contact with these system integrators and OEM customers.
Okay, very good. I guess, well, I hope we can connect you with these end users, so you can ask us at the end of the meeting and we can do it, okay? So we have a question from Alejandro from the Iris Technology Solution for you. Alejandro, would you like to make the question by yourself?
Yes, for sure. Yeah. Okay. No, we are clients of Avantis. In fact,
good to hear.
Yeah, we're clients. And 1 year ago, we were testing the small layout spectrophotometer that you have, the one that you have in your screen right now. Okay, I'm seeing. Okay.
Oh, this one at the back.
Exactly, exactly, yeah. Exactly. And in fact, we confirmed that the performance was good enough for a lot of different applications, because as you mentioned, we are integrators. So basically, this is the type of devices that we use for integrating in the solution that we deliver to the clients. And I remember we got a good performance, but the representative for Avantis told us that, well, maybe it could take about several months to be launched to the market. And my question basically is this concept, this device, available for ordering right now?
Yes, it is. We launched it in, let me think, in April last year already. So we already have the first, a little bit later. So it has been launched in 2019. At the moment, it's available, easy to produce. So we can get into contact, create prototypes, discuss the configuration you need, and it is commercially available.
Great. Okay, thank you very much. Yes, we will take it into account. Okay.
Okay.
Okay, very good. It sounds like a plan. So then more questions or comments for Gerd? Okay, because we have one person here in the room that I would like to introduce you, is Thierry from Cilios Technologies. Thierry, are you here?
Yes, I am.
Hello, how are you doing?
Can you hear me? I'm fine, thanks.
Very well. So
Okay.
is a good moment for you to introduce what is Cilios doing?
Yeah. So Cilios, I have a small presentation. I don't know if it's possible to go quickly on it or not.
Go quickly, yes.
Well, okay, so it's puzzling. So okay, I'm gonna just say by voice. Okay, Cilios, we're a small company in the south of France. So just a joke for Jose introduction, saying that Bath is one of the nicest city he has seen. Okay, just come to around Marseille or Aix-en-Provence and you see what is beautiful. So about that joke, so Cilios is making micro-optics on mainly for this application, multispectral filter that can be fully customized to any different part of the visible to near spectrum. And we apply it to any type of sensors. So we can fully customize your multispectral sensor. So it's something that weighs only a few grams, and that can be placed on board on, let's say, robots and things like that, drones, etc. And we have also on the shelves cameras to start, let's say, develop the application with a low investment. Currently in the multispectral cameras or pixelized filters, we estimate that we are one of the cheapest on the market worldwide. And then we can, after the customer has made his, let's say, the validation, he comes to us and say, I want you to use this sensor for whatever reason. Then I want you to have implement this wavelength, this wavelength, this wavelength. And we can also develop the filter with any matricial organization or line organization or random or custom buyer, 2x2, 3x3, whatever. Okay, and then the customer has his own sensor developed for his own application. And in the let's say agro-food market, we have let's say developed something for let's say agro let's say institute, mainly in Europe, and our things have been applied for the detection of the small spider mite in tomato, aphid in vineyards, early detection of oidium in vineyards, detection of fusarium head blight in ears of soft and durum wheats, etc., etc. Apple scab for more precision. And also we have developed some filter to be for the CNES, or the French Space Agency, under the umbrella of ESA, for CubeSats. So that's means for
Thierry, Cilios is one of these companies that inspires me, because you make these micro optics for almost any environment. I live in Northvik at the European Space Agency. So whoever is looking for optics for harsh environments, these people not only know how to make optics, but they know the needs of your customers to optimize those products. Cilios is one of the companies, an ideal partner for the optics manufacturing, and it's so great to have you. Your city is also beautiful, Marseille. I'm actually going there for summer, so I'm gonna come and visit.
That's fine.
Why don't we go to the last speaker today? Why don't we go to this fantastic new young company, Hypes? The reason we wanted to give you the final spot is because you wanted to let us go for the weekend in the right way. The floor and the attention of everyone goes to one of the newcomers in this industry, and newcomers to Epic. The floor and the attention of everyone goes to you.
Thanks a lot. So yeah, hi from the heart of Germany. We are sitting in Hanover right now. So we are working since 2 years in hyperspectral in horticulture and agriculture. My name is Juarez. I'm the co-founder and CEO of Hype Solutions, and I will show you a bit what we are doing today. So everyone knows for sure what is hyperspectral used for, but a short introduction for what we use hyperspectral imaging. The detection of plant stress in general, but more especially in detection of plant diseases. And so this little diagram shows very good, I think, how this detection works. So most of you probably know all this, but what we do is to measure the difference between the different wavelengths in terms of the healthy plant, the diseased plant, or the senescent plant. So let's be quick and do not take too much time. So what we offer you is we do user-friendly hyperspectral imaging technology. So basically we have 2 products at the moment. The one is called Black Box and the one is called Blackbird. So the first one is like basically a plant phenotyping box, which can be used in greenhouses especially. We have worked a lot with sugar beets lately, but also with hop in our latest project. And we have a very compact and lightweight camera, which just makes it very useful to use on drones. And this is why we put our camera onto the DJI drones. And if you have any use case, which is not mentioned here, feel free to contact us. We also do like custom solutions for you. We are very agile in working with hyperspectral imagery. But I want to go more detail into our drone solution. So what we have is a very lightweight and compact camera, as I mentioned already. It weighs only 300 grams and has a very high spectral quality. So we have from 500 to 1,000 nanometers at the moment, and we are developing a new one in the future up to 1,700 nanometers. And what we did is we found out most of our customers didn't have a very appropriate user-friendly solution, and most of the problems were in the connection between drone and camera. So we have a drone and we have a camera, but the connection between is very difficult for most of the people. And so what we figured out is, okay, we are right now in the DJI developer program and developing on the DJI Matrice 200 and 300 series. So yeah, most of the DJI drones are very easy to use. They are commercially available. This is also one of the main reasons for us to use this platform. And yeah, with this platform, you can also use different sensors on the same drone platform. So if you want to use, for example, thermal imagery, you could combine that with our hyperspectral imagery. And that's one of the biggest reasons for us to use this platform. And in combination with our cameras, also reference sensor, so that you also can capture in changing light conditions, which is very important if you want to use hyperspectral imagery on a large field. So yeah, basically that's it. I don't want to take too much time, as everyone for sure wants to enjoy the weekend. So what we are looking for, especially for research institutes, so always in horticulture, agriculture, as this topic here on the meeting. And we are also looking for strategic partners, especially in sales. So we are nearly done with our product development and we want to start shipping next year. So if there are any partners who are looking forward, feel free to contact. And we are already always interested in pilot projects, but also technical feasibility studies. May it be horticulture, agriculture, but we are very open to other fields of usage. We heard one of using for mining, so that could also be one use case. Feel free to contact us. Here are my contact details, and hope you have maybe some questions for me.
Thank you very much for a great presentation. I think we have a lot of room for questions, but what we do have also is a lot of room for having a great weekend. So what I'm going to do is, if anyone has a question right now, can raise a hand. 3, 2, 1, 0, and we go to Ivan Kostadinov. Can you unmute? Then we go to Avantes, and then we go to have a great weekend.
Yes, I'm interested in hyperspectral measurements devices because our from BNT we developed such kind of devices, and we already tried them in the agriculture. But initially, the device based on the acousto-optical technology, that is the spectrometer, imaging spectrometer operating in 390 to 610 nanometers. It is very limited spectral interval, but it is the prototype. So we are dealing with the hyperspectral measurements, and we would like to establish contacts with both companies, is Silius and HAPE.
Yeah,
okay.
Of course. Yeah, let's stay in contact afterwards, maybe.
And now let's go to Avantes now. Her. From beautiful
Sorry,
Apeldoorn.
I was waving, but I was saying goodbye to somebody who was leaving. So
which is good because you know Avante's CEO is the president of Epic, Benno Oderker. Hi Benno. I'm gonna give Avante's the final remarks today. I always choose a company to give us the final remarks. Her, what is the summary of this meeting? What do you take away for the weekend?
I take away that I'm quite surprised that thanks to this Corona, so to say, that this online meetings is still quite an effective way to meet the vertical chain of all people together within a very limited time frame. Maybe we should comprise it a little bit to 2 hours to get the attention span. That's my only suggestion. But I'm very happy to see all the disciplines in this market coming together and seeing what's happening to get a total overview.
Thank you, Elf. You know what happens when you do it in 2 hours? People say that you should do it in 1 hour and a half. I know that because I've done it. I take away a few things. The first one is the big market trend is the lighting, and the market need is obviously was very well expressed by SANlight. They were talking about reduce the water, reduce the energy consumption, reduce the air personnel, and reduce the space, going towards hydroponic systems. And they were talking about Horticulture 4.0. We saw two big arms in this meeting: the lighting with the SANlight lighting simulating the sun, and it's so great presentation from Seoul Semiconductors. We had the presentation from SANlight. We'll always remember when he woke up, he got up and he walked around the cannabis plantation. And then we also see the next trend is the lighting in water directly into the root using UV, which is a market that we need to explore deeper. In the imaging, spectroscopy, and sensing, we have great presentation from Senorics, from TU Eindhoven. On the next stage, we have a great presentation from Gamaya on the observation from far away, and we talk about really mobile and stationary solutions, covering the need of John Deere, especially on dry matter, total nitrogen, ammonium, nitrogen, phosphate, potassium. We can monitor this because Agri-photonics is here. It is 5:35. Sorry for this extra 5 minutes. Have a great weekend. Enjoy the sun and work a little bit on your garden like I will. Take care. See you soon. Bye-bye.
Thank you, Jose.
Bye-bye.
Thank you.
Thank you so much.
Thank you. Bye-bye.
Bye-bye.